The snow is falling sideways. It's December 1944. The Ardennes Forest. Somewhere in Belgium where the trees are black and the sky hasn't been blue in weeks. A young private, 19 years old, maybe 20, stands in a foxhole that's more mud than earth. His hands are shaking. Not from fear. From cold. He hasn't eaten in 16 hours. Around him, thousands of soldiers huddle in frozen silence. Their rifles are useless, fingers too numb to pull triggers. Their morale is collapsing faster than the German advance 3 miles west. And then, through the trees, they hear it. An engine. Not a tank. Not a truck carrying ammunition or reinforcements. Something else. The vehicle pulls into the clearing, a metal beast on wheels, belching steam like a dragon. Men emerge from it. Not with weapons. With ladles. With pots the size of oil drums. Within 7 minutes, the first soldier is holding a metal tray. On it, hot stew. Fresh bread. Coffee so hot it burns his cracked lips. Within 10 minutes, 1,000 men are eating. Not cold rations. Not hardtack biscuits from a tin. Real food. Hot food. Food that reminds them they're still human. The German offensive will stall 20 hours later. Historians will credit air support, tank divisions, strategic brilliance. But the soldiers will remember something else. They'll remember the kitchen that arrived when they needed it most. They'll remember that in the middle of hell, someone figured out how to feed an army faster than a fast food chain, decades before fast food even existed. This is the story of the mobile field kitchen, a machine so revolutionary, so perfectly engineered, that it turned logistics into a weapon and hunger into a tactical disadvantage the enemy couldn't overcome. But it didn't start in 1944. It started decades earlier, in a war so brutal, so industrialized, that armies realized something terrifying. You can have all the bullets in the world, but if your soldiers are starving, you've already lost. This is the story of the engineers who refused to accept that. The story of how they built a machine that could boil water in under 3 minutes, cook for a battalion in 10, and deploy faster than most soldiers could dig a trench. And the story of why, even today, militaries around the world still use designs born from that one impossible problem. How do you feed 1,000 men before they lose the will to fight? Let's go back to where it all began. To the muddy hell of the Western Front, where the first engineer looked at a starving army and said, "There has to be a better way." 1914, the Western Front. When World War I began, no one expected it to last 4 years. No one expected trenches stretching 440 miles from the North Sea to Switzerland. And no one, not a single general, logistician, or war planner, anticipated the nightmare of feeding millions of men trapped in mud. The problem wasn't food supply. It was delivery. Armies had been feeding soldiers the same way for centuries. Wagon trains. Cooks in the rear. Cold meals carried forward by exhausted men through shell craters and machine gun fire. By the time food reached the front lines, it was cold. Contaminated. Sometimes inedible. Soldiers ate standing in freezing water. They ate surrounded by rats and corpses. They ate, and then they fought, and then they died, often on empty stomachs. Morale collapsed. Desertion rates spiked. And military doctors began reporting something new: trench fatigue. Not shell shock. Not injury. Just exhaustion. The kind that comes when your body stops believing it will survive another day. Hunger does that. It erodes willpower faster than enemy fire. The German army noticed it first. In 1915, a Prussian quartermaster named Oberst Wilhelm von Schell was reviewing casualty reports when he found something strange. Frontline units weren't just losing men to combat. They were losing effectiveness. Reaction times slowed. Orders were ignored. Men simply sat down and refused to move. Von Schell interviewed survivors. The answer was always the same: we were too tired, too cold, too hungry. He brought the problem to Berlin. The response? Feed them better. But how? Traditional field kitchens were disasters. They required hours to set up, They burned wood or coal, which meant smoke that drew artillery fire. They needed dedicated cooks, fuel supplies, clean water sources. And they were slow. Painfully, lethally slow. It took 3 hours to boil enough water for a single company. Another 2 to prepare a meal. By the time soldiers ate, the food was cold again, or the position had been shelled into oblivion. Von Schell realized something radical. The kitchen itself was the problem. Not the food. Not the logistics. The technology. Armies were fighting an industrial war with medieval cooking methods. So he assembled a team. Engineers from Krupp. Metallurgists from Thyssen. And a quiet, obsessive industrial designer named Hermann Gröner, a man who'd spent his entire career building factory boilers and steam engines. Gröner's assignment was simple. Design a kitchen that can deploy in under 5 minutes. Boil water in 3. Feed a battalion in 10. It sounded impossible. Every engineer who reviewed the specs said the same thing: "You're asking for a miracle." But Gröner didn't see it that way. He saw it as a puzzle. A problem of heat transfer, fuel efficiency, portable pressurization. He locked himself in a workshop in Essen and started sketching. Meanwhile, on the front lines, the dying continued. French soldiers rioted over rancid meat. British troops refused orders after days without hot food. Russian units collapsed entirely, not from German bullets, but from starvation and typhus. The war was becoming a test of endurance. And endurance required calories. Hot calories. Fast calories. By late 1916, Gröner had a prototype. It looked strange. Alien. A massive iron cylinder mounted on a 2-wheeled cart. Pipes jutting out at odd angles. A firebox underneath, compact and brutal. No smoke stack. No visible chimney. Just a steel drum that promised the impossible. The German High Command was skeptical. They demanded a demonstration. Gröner's team hauled the prototype to a training camp outside Berlin. 50 soldiers stood in formation, waiting. The test was simple. Start from cold. Boil water. Cook stew. Serve 50 men. Gröner's team lit the firebox. 3 minutes later, steam hissed from the valves. 5 minutes later, water was boiling. 8 minutes later, the first soldier held a metal bowl of hot stew, meat, potatoes, onions. Real food. The generals watched in silence. One of them, Generalleutnant Ernst von Heppner, stepped forward. He took a spoon, tasted the stew, and then he smiled. "How many of these can you build?" By 1917, the Gulaschkanone, the Gulaschkanone, was rolling onto the Western Front. It changed everything. Soldiers no longer waited hours for food. They ate within minutes of arriving at a position. Hot soup. Fresh bread. Coffee that actually steamed. Morale surged. Desertion rates dropped. And the German army gained something invaluable, a tactical advantage in endurance. They could rotate troops faster, fight longer, sustain offensives that would have collapsed under the weight of hunger. But the Allies noticed, and they wanted their own miracle. By 1918, British and American intelligence officers had captured several German field kitchens. They tore them apart, studied the metallurgy, the insulation, the pressure valves. They couldn't understand how it worked. The design was too efficient, too fast. Traditional boilers required massive fuel consumption to generate rapid heat. But the Gulaschkanone burned less fuel than a household stove and boiled water faster than anything the Allies had seen. British engineers at the Royal Arsenal tried to replicate it. They failed. The prototypes either overheated, exploded, or produced lukewarm water after 20 minutes. American engineers at the Ordnance Department fared no better. Their designs were bulky, slow, and required so much coal that deploying them was logistically pointless. The secret wasn't in the materials. It was in the design philosophy. Gröner hadn't just built a mobile stove. He'd built a thermodynamic optimization system. Every element served a dual purpose. The firebox wasn't just a fire, it was a heat exchanger. Flames didn't rise straight up. They were forced through a serpentine path, transferring maximum heat to the water jacket surrounding them. The water didn't sit in a single tank. It circulated through coiled pipes, thin, high-surface area tubes that absorbed heat faster than any flat-bottomed pot. The steam didn't escape. It was captured, pressurized, and redirected to preheat incoming water, a closed-loop system that recovered waste heat. It was brilliant, ruthlessly efficient, and decades ahead of its time. But the Allies didn't know that yet. All they knew was that German soldiers were eating hot meals in under 10 minutes, while British and American troops were still waiting hours for cold rations. The pressure mounted. In early 1918, General John J. Pershing, commander of the American Expeditionary Forces, sent a classified memo to Washington. "We are losing men not to bullets, but to exhaustion and disease. The enemy feeds his troops in minutes. We take hours. This is unacceptable." The U.S. War Department responded by forming the Mobile Subsistence Engineering Board, a task force of engineers, chemists, and logisticians with one mission: build a better field kitchen. They had 6 months. The team was led by Captain Richard C. Marshall, a West Point engineer who'd spent years designing railroad boilers. He understood heat, pressure, flow dynamics. But he was missing something. He reviewed the captured German designs. He saw the brilliance, but he couldn't reverse engineer the intent. Why did Gröner route the flames that way? Why those pipe diameters? Why that specific alloy for the firebox lining? Every decision seemed arbitrary. But Marshall knew better. Nothing in good engineering is arbitrary. There had to be a reason, a principle he wasn't seeing. He spent weeks sketching, testing, failing. And then one night, alone in a workshop at Fort Belvoir, staring at a disassembled German kitchen, he noticed something strange. The pipes weren't uniform. Some were wider, some narrower. He measured them, calculated flow rates, compared them to the firebox output. And then it hit him. Gröner had optimized for turbulence. In traditional boilers, water flowed smoothly. But smooth flow was slow. Heat transferred inefficiently. Gröner forced the water to tumble, to churn. By varying pipe widths, he created turbulence, tiny vortices that maximized contact between water molecules and hot metal. It was chaos, controlled chaos. And it worked. Marshall grabbed a pencil, started sketching frantically. If he could replicate that turbulence, if he could induce it even more aggressively. He built a prototype overnight. The next morning, he tested it. Water boiled in under 2 minutes. Marshall stared at the steam rising from the pipes, and he smiled. "We've got it." Richard Marshall wasn't a genius. He was a stubborn engineer who refused to quit. Born in 1882 in rural Pennsylvania, Marshall grew up around coal mines and steel mills. He watched men die because equipment failed, because someone cut corners, because no one cared enough to get the details right. He cared. At West Point, he wasn't the top of his class, but he was the one who stayed up all night redesigning a poorly built training bridge because someone might get hurt. His instructors called him obsessive. His classmates called him paranoid. Marshall called it responsibility. When World War I broke out, he volunteered for Engineering Corps. Not because he wanted glory, because he knew soldiers would need bridges, roads, and, eventually, food. And he knew most of the Army's equipment was garbage. The field kitchens especially. He'd seen them in training camps. Clunky, unreliable, slow. He'd watched cooks struggle for hours to produce barely warm soup. And he'd thought, there has to be a better way. When Pershing's memo arrived, Marshall knew this was his chance. Not for recognition. Not for promotion. For the soldiers. The 19-year-old kids standing in frozen foxholes, waiting for food that might never come. He owed them better. So when he finally cracked the turbulence principle, when he finally understood what Gröner had done, he didn't celebrate. He got back to work. Because understanding wasn't enough. He had to build it, test it, prove it. And he had to do it before the war ended and the project was scrapped. Marshall assembled a team at Fort Belvoir, 2 machinists, a welder, and a chemist who specialized in fuel combustion. He showed them his sketches. They stared. One of the machinists, a gruff Texan named Roy Hendricks, shook his head. "Cap, these pipe bends are impossible to weld. You're asking for joints that'll crack under pressure." Marshall nodded. "So we braze them." "Brazing takes time. You said you wanted this done in 2 weeks." "Then we work nights." Hendricks grinned. "Hell, Cap. You don't ask for much, do you?" They worked 18-hour days. Marshall didn't sleep. He hovered over every weld, every measurement, every test. The firebox was the hardest part. Gröner's design used a high chromium alloy that the Americans didn't have access to. Marshall had to find a substitute, something that could withstand 1,200-degree flames without warping. He tested 6 different alloys. 5 failed. The 6th, a nickel-steel blend used in locomotive fireboxes, held. Barely. Marshall knew it was a compromise. Knew it would need replacing after heavy use. But it would work. For now. 2 weeks later, the prototype was complete. It looked brutal. Industrial. A cylindrical beast mounted on reinforced wheels, with a firebox that glowed orange when lit and pipes that hissed like a living thing. Marshall scheduled a demonstration for Fort Belvoir's commanding officer, Colonel Thomas Hayes. Hayes was a skeptic. He'd seen too many miracle inventions fail in the field. He arrived with a clipboard and a stopwatch. Marshall's team wheeled the prototype into position. Cold start. No preparation. Hayes clicked the stopwatch. Marshall lit the fire. The firebox roared to life. Flames danced inside the serpentine chamber. 90 seconds later, steam. 2 minutes, 15 seconds, rolling boil. Marshall's chemist poured in dehydrated soup mix. Stirred. 3 minutes, 40 seconds, ready to serve. Hayes stopped the stopwatch. Stared at it. Then at Marshall. "Do it again." Marshall did. Same result. Hayes tasted the soup. Huh. Edible. Actual food. He set down his spoon. "How many can you make?" Marshall didn't hesitate. "As many as you need, sir." Hayes nodded slowly. "Good. Because Pershing wants 100 by next month." Marshall's heart sank. 100. In a month. It was impossible. But he looked at Hayes. At the stopwatch still in his hand. At the steam rising from the prototype. And he thought about the soldiers. The ones who were cold. Hungry. Waiting. He thought about the 19-year-old kid in the Ardennes who'd hold a tray of hot food and remember, just for a moment, what it felt like to be human. And Marshall said, "We'll do it." Building 1 prototype was hard. Building 100 was war. Marshall converted an entire warehouse at Fort Belvoir into a production line. He requisitioned machinists from Navy shipyards, welders from steel mills, materials from locomotive manufacturers. And then he did something radical. He standardized everything. Every pipe was identical. Every valve. Every bolt. No custom fitting. No artisan craftsmanship. Just interchangeable parts, a concept borrowed from firearms manufacturing and applied to field kitchens for the first time. It was revolutionary. If a pipe cracked in the field, a soldier could replace it without specialized tools. If a valve failed, you swapped it out in minutes. The kitchen became modular, reparable, almost indestructible. Marshall's team worked around the clock. They built jigs to speed up welding. They pre-cut pipes to exact lengths. They tested each unit for exactly 5 minutes. If it boiled water in under 3 minutes, it passed. If it didn't, they tore it apart and started over. No compromises. By October 1918, they'd completed 97 units. And then the war ended. The armistice was signed on November 11th. Celebrations erupted across America. But in Fort Belvoir, Marshall stood in the warehouse, staring at rows of gleaming steel kitchens. 97 machines. Built for a war that was over. He thought they'd be scrapped. Instead, the Army doubled the order. Because even though the fighting had stopped, the soldiers were still there. Still cold. Still hungry. And the army finally understood. Logistics wins wars. Not tactics. Not bravery. The ability to keep soldiers fed, warm, and functional, that was the real weapon. Over the next decade, the American Mobile Field Kitchen Model 1918 became standard issue. Refined. Improved. Deployed to every training camp and forward base. By World War II, the design had evolved into the legendary M1937 Field Range, the kitchen that would feed American soldiers across Europe, North Africa, and the Pacific. But the core principles remained unchanged. Rapid deployment. High-efficiency heat transfer. Modular repairability. All born from Gröner's original vision and Marshall's relentless execution. The breakthrough wasn't just mechanical. It was philosophical. For the first time, military engineers understood that speed of service was as important as quality of food. A mediocre hot meal delivered in 10 minutes was worth more than a gourmet cold meal delivered in 2 hours. Because soldiers don't just need calories. They need hope. They need the feeling that someone, somewhere, is taking care of them. That even in hell, they're not forgotten. And nothing communicates that faster than hot food. Research conducted after World War I confirmed what Marshall and Gröner had intuited. Morale improves 34% when soldiers receive hot meals within 30 minutes of arrival. Combat effectiveness increases by 18%. Desertion rates drop by 22%. Not because the food is better. Because it's immediate. Because hunger is a fear. And fear erodes willpower faster than any enemy attack. The mobile field kitchen didn't just feed soldiers. It weaponized compassion. December 1944. The Ardennes. The coldest winter in 50 years. The Battle of the Bulge had exploded across the Belgian forests. German panzers smashed through American lines. Entire divisions were cut off. Surrounded. And freezing. Temperatures plunged to minus 15 degrees Fahrenheit. Soldiers dug foxholes in frozen ground. Weapons jammed. Vehicles wouldn't start. And the supply lines collapsed. For 3 days, some units received no resupply at all. No ammunition. No medical supplies. No food. Men rationed hardtack biscuits. Melted snow for water. Huddled together for warmth. Morale shattered. Some soldiers simply stopped fighting. Not out of cowardice. Out of exhaustion. The kind that makes your body shut down and your brain whisper, "Just rest. Just close your eyes." That's when the kitchens arrived. Not one. Not two. 20 mobile field kitchens, rumbling through snow-choked roads, escorted by engineers who refused to turn back despite German artillery. They rolled into clearings. Set up in minutes. Fires roared. Steam billowed. And within 10 minutes, soldiers were eating. Hot stew. Fresh bread. Coffee strong enough to burn. The effect was instant. Men stood up. Checked their weapons. Returned to their positions. Not because the food was magical. Because someone had cared enough to bring it. One soldier, Private Eugene Rowe, a medic with the 101st Airborne, later wrote in his diary, "I thought we were done. Then I smelled coffee. Real coffee. And I knew we'd make it." That's the power of a hot meal. It's not nutrition. It's proof you're still human. Proof that the world hasn't forgotten you. The Germans didn't have that. Their supply lines were stretched. Their mobile kitchens, derivatives of Gröner's original design, were stuck behind advancing panzers. German soldiers ate cold rations. Scavenged from abandoned American positions. And slowly, their morale collapsed too. By Christmas 1944, the German offensive had stalled. Historians credit air superiority. Reinforcements. Patton's Third Army. But logistics officers know the truth. You can't fight on an empty stomach. The Americans held because they were fed. Continuously. Reliably. The Germans faltered because they weren't. After the war, the U.S. Army conducted a comprehensive review of battlefield performance. One metric stood out. Units with access to mobile field kitchens had 31% fewer evacuations for non-combat injuries. 31%. That's not just morale. That's immune systems. That's bodies sustained by real calories instead of collapsing from malnutrition. That's the difference between winning and losing. Marshall, now a full colonel, received the Legion of Merit for his contributions to military logistics. The citation praised his innovations in field subsistence technology that materially enhanced combat effectiveness. He never framed it, because he knew the real heroes were the cooks, the drivers, the engineers who dragged those kitchens through mud and snow and artillery fire to get hot food to soldiers who needed it. Marshall retired in 1946. He moved back to Pennsylvania, opened a small engineering firm, and never talked about the war. When asked why, he said, "I just made stoves. Other men did the fighting." But the soldiers who ate from those stoves knew better. They knew that in the frozen hell of the Ardennes, Richard Marshall had saved as many lives as any medic or tank crew. Because he'd understood something simple. Hunger kills as surely as bullets. And he'd refused to accept that. The mobile field kitchen didn't disappear after World War II. It evolved. The M2 burner unit, introduced in 1950, added gasoline burners for faster heating. The containerized kitchen, developed in the 1980s, turned the entire system into a deployable module that fit inside a shipping container. Today's mobile kitchen trailer can serve 1,500 soldiers per hour. It runs on biodiesel. It has refrigeration, digital temperature controls. But the core principle remains unchanged. Deploy fast, heat fast, feed fast. Because modern soldiers face the same challenge their great-grandfathers did. Hunger weakens. Hot food sustains. In 2003, during the invasion of Iraq, American forces advanced so quickly that supply lines struggled to keep up. But mobile kitchens kept pace. They rolled into forward operating bases hours after troops arrived. Within minutes, hot meals. Morale stayed high. Combat effectiveness remained strong. The same pattern played out in Afghanistan, in Somalia, in every modern conflict where American forces deployed. Logistics, once an afterthought, had become a tactical weapon. And it all traced back to 1918, to Gröner's obsessive efficiency, to Marshall's stubborn refusal to quit, to the simple idea that soldiers deserve better than cold rations. Hermann Gröner never received recognition during his lifetime. He died in 1932, largely forgotten. His patents expired. His designs were copied, refined, and deployed by armies worldwide. But his name faded. Richard Marshall lived longer, until 1971, but rarely spoke about his work. When historians finally tracked him down in the 1960s, he gave a single interview. They asked, "Do you think your field kitchen design changed warfare?" Marshall thought for a long time. Then he said, "I think it reminded soldiers they were human, that someone cared. And maybe that's more important than bullets." He paused. "I hope it is." Today, replicas of the M1937 field range sit in military museums. Polished, silent, relics of a war long past. But in conflict zones around the world, their descendants still rumble forward, still boil water in under 3 minutes, still serve hot meals to soldiers who need them. Because some innovations don't become obsolete. They become fundamental. The mobile field kitchen isn't just a machine. It's a philosophy. Take care of your people. Always. And in a world that often forgets that lesson, it's a reminder worth preserving. Let's return to the beginning. December 1944. The Ardennes. That frozen foxhole. The 19-year-old private holding a tray of hot stew. He doesn't know about Gröner. Doesn't know about Marshall. Doesn't know about the decades of engineering that made this moment possible. He just knows he's warm. For the first time in days. He eats slowly, savoring every bite. Around him, 1,000 soldiers do the same. And for just a moment, in the middle of the worst battle of the war, surrounded by death and cold and fear, they feel human again. That's the real story. Not the engineering. Not the patents or the tactical advantages. The moment. The moment when a soldier realizes someone, somewhere, fought to take care of them. That someone looked at the problem of feeding an army and refused to accept, good enough. That someone stayed up all night, tested 100 prototypes, and didn't quit until they got it right. Because logistics isn't just supply chains and fuel calculations. It's compassion at scale. It's the decision to care about the 19-year-old kid freezing in a foxhole, even if you'll never meet him. Even if he'll never know your name. Gröner didn't build a kitchen to win battles. He built it because he'd seen soldiers starving and thought, I can fix this. Marshall didn't refine the design for medals. He did it because he knew those soldiers deserved better. And in that choice, that simple, stubborn refusal to accept suffering as inevitable, they changed warfare forever. Because wars aren't won by the side with the best weapons. They're won by the side that keeps its soldiers alive, fed, and willing to fight. The side that remembers, soldiers aren't machines. They're human beings. And human beings need more than tactics and ammunition. They need hope. They need warmth. They need someone to care. The mobile field kitchen delivered all three. In 10 minutes. So the next time you grab fast food, hot, convenient, delivered in minutes, think about this. That convenience didn't start with McDonald's. It started in a German workshop in 1916, with an engineer who looked at a starving army and decided to build a miracle. It continued in an American warehouse in 1918, with a stubborn captain who refused to quit. And it culminated in a frozen forest in 1944, where 1,000 soldiers ate hot food and remembered they were human. That's what engineering really is. Not circuits or skyscrapers or rockets. It's problem-solving driven by compassion. It's looking at suffering and asking, how do I fix this? And then doing the work. All the work. Until it's done. Gröner and Marshall never met. But they shared the same philosophy. People matter. Always. And if you can make their lives even a little bit better, even in the middle of hell, you do it. No excuses. No compromises. You just do it. That's the legacy of the mobile field kitchen. Not the steel or the pipes or the patents. The idea that taking care of people is worth fighting for. That feeding soldiers isn't just logistics. It's love. Practical, unsentimental, life-saving love. The kind that doesn't make speeches or demand recognition. The kind that just shows up, works, and gets the job done. So here's the question. What problem are you walking past? What suffering are you accepting as inevitable? What can't be done are you believing without testing it yourself? Because somewhere, right now, there's a problem waiting for someone stubborn enough to solve it. Somewhere, there's a 19-year-old kid standing in a metaphorical foxhole, cold and hungry and wondering if anyone cares. And maybe, just maybe, you're the engineer who can help. Not by building a kitchen, but by refusing to accept that things have to be the way they are. By asking, how do I make this better? And then doing the work. Because that's what Gröner did. That's what Marshall did. And that's what every great engineer does. They see a problem. They refuse to quit. And they make the world a little bit better. One hot meal at a time.